Okay, let's go through some of the Pythagorean theorem in 3D practice problems. So there is a couple type of problems that could be hard. The other two should be easy, but again, you're trying to get 100% on this. So let's just go through 4 examples, or 2 or 3 of them at least. All right, the only thing complicated about these is being able to interpret the diagram that they give you. So let's see what diagram they give us here first. All right, and I'm going to zoom in here. Okay. So they tell us that each vertical cross-section of a triangular prism shown below is an isosceles triangle. So since this is isosceles, again, we know that this is going to be a perpendicular bisector. So I want to zoom in again a little bigger. Maybe smaller, maybe, I don't know. Okay, so here's our triangle. Here's our right triangle we're looking at. The height's going to be h. Again, this is a perpendicular bisector, so we cut it in half. So this piece right here is 3. We know the hypotenuse is going to be 3 root 2. Okay, and then the other leg is h. So we're using the Pythagorean theorem, so we want to use a squared plus b squared equals c squared. All right, so your two legs are a and b. That's going to be h and 3. So we're going to have 3 squared plus h squared equals your hypotenuse squared, which is 3 root 2. Okay, 3 squared is 9. So we have 9 plus h squared equals 3 root 2 squared. So 3 times 3 is going to be 9. Square root of 2 times square root of 2 is 2. Okay, so you should have 9 plus h squared equals 18. Okay, we subtract 9 from both sides. We get h squared equals 9. To get rid of the square, we got to do the inverse operation, which is square root. So we square root both sides. So h is going to be plus or minus 3. But we don't want the negative because we're dealing with length. So the height here is going to be 3 units, whatever those units would be. Okay, so we can put in 3. Check our answer. And we're good. All right, on to the next one. Next question. Okay. So here we have a square pyramid shown below with a base of 10. The slant height of the pyramid is 8. That's this distance here. And we're looking for h, the vertical height. Okay, so since this is a square pyramid, we know that this point's going to be in the middle. So we can say that this piece here is 5, right? So this piece here would also be 5, right? But we're just looking at this triangle here. So half of 10 is going to be 5. So if we divide 10 by 2, we get 5 and 5. All right, so we know that that piece of the triangle there is going to be 5. Since it's a right triangle, we can simply use the Pythagorean theorem. A squared plus b squared equals c squared. The legs of this right triangle are h and 5, so we have h squared plus 5 squared equals 8 squared. So we have h squared plus 25 equals 64. We subtract 25 from both sides. We get h squared equals right, that's going to be 39. Okay, to get rid of the square, we got to square both sides. So we have h equals the square root of 39. It wants our answer rounded to the nearest tenth, so that's one decimal place. So we're going to do square root of 39. Okay, and that's going to give us 6.2. So that's approximately 6.2. Let's put our answer in. We hit check answer down here, and we're good. All right, this is the one that might be tricky. You got to do the Pythagorean theorem twice. We want to know the diagonal of this cube. All right, so the first thing we want to look at here is this triangle of the cube. Okay, so this is going to be 60. This side's 60, so we know this side over here is also 60. Okay, so we have 60, 60, and then we can find our hypotenuse here. So we're going to do a squared plus b squared equals c squared. Okay, our a and our b are 60 and 60, so we're going to do 60 squared plus 60 squared equals c squared. 60 squared is 3,600. So plus 3,600 equals c squared. So 7,200 equals c squared. Then we take the square root. $7,200, and that's going to be equal to 84.9. Okay, so approximately 84.9 equals C. Okay. All right. So now we can look at our second triangle here, which is this one right here. Okay, and we have a right angle here. The base here we know is 80. Let me pick up the best color. 4.9. Okay, and then we know the height over here is going to be 60. Let's just use a different color. Let's just use the red. All right, we found this to be 84.9. This is 60, so we know the height back here is also going to be 60. Okay, and then we can use the Pythagorean theorem to find d here. So we can do a second one over here. So we have a squared plus b squared equals c squared. Okay, so that's going to be 60 squared plus 84.9 squared equals c squared. Okay, and so let's put that all in the calculator. So 60 times 60 plus 8. That should be 7,200, right? Plus 84.9. So we don't need to necessarily use the calculator. 60 squared is 3,600. We know 84.9 squared is going to be 7,200. Okay, so this gives us 108. 10,800. So 10,800 equals c squared. All right, and then we got to put that in the calculator. So square root of 10,800 it's going to be 103.9. So plus or minus 103.9, but we want the positive distance, or the positive distance because we're dealing with length. Okay, so that leaves us 103.9. That's rounded to the 10th place, right? You know, 1 decimal place, that's the 10th place. So 103.9. Let's see if we got it right. 103.9. Great. All right, so we had to first do the first triangle down here, the small one. Right, we had to do this right triangle down here to find the, and we had to find the hypotenuse. It was 60 by 60. And then we had to do this blue triangle here, which was a second right triangle. And using that hypotenuse of the red one and the height here, 60, we could find our D value, which was 103.9. All right, let's see what the next one is. Okay, the triangular prism shown below is 6 centimeters wide and 4 centimeters deep and has a vertical height of 7. Okay, what is the edge length of the triangle? Okay, so we have let's do red. A vertical height here. It's not very good. Okay, vertical height of 7. 6 centimeters wide and 4 centimeters deep. So the whole thing here is 6. Okay, since it looks like, since it's a regular triangular prism, we know that since it's 6 centimeters wide, you can split it in half. So you have 3 and 3. This piece will be 3. This piece will also be 3. So the whole thing will be 6. If we just have to look back at our isosceles triangle practice there for the Pythagorean theorem. Okay, and then we can use our formula: a squared plus b squared equals c squared. Okay, so we're looking at 3 squared plus 7 squared equals c squared. That's going to be 9 plus 49 equals c squared. That's going to be 58 equals c squared. Square root both sides, so you get the square root of 58. 58 equals C. Okay, and we want to use the calculator then to find the decimal to the nearest 10. So square root of 58. And we, oops, we didn't do it. That equals 7.6. Okay, so we can then put our answer in 7.6. And we're good. So that is the run through of 4 of the possible problems on the Pythagorean theorem in 3D practice.